The planet Earth, home to billions of human beings, all seeking to improve their lives and future. This fragile bubble of life is being pushed to its limits. Earth's resources are dwindling and its living systems are being destroyed. We're filling the air with carbon dioxide. Forests and lakes are dying from acid rain. We're poisoning our seas with hazardous waste and rapidly depleting our precious natural resources. For the first time in human history, there is the threat of a single accident or military action which can destroy our world. There are fewer and fewer choices for our children. The dream of a better and brighter future for each generation is fading. It is time to face the fact that we cannot continue this way. We can solve the problems we're facing. The future is not a dead end. To save tomorrow, we must begin today. We must begin worldwide conservation efforts, and wherever possible, we should use the Earth's renewable resources. Resources such as wind, water, and ground-based solar power. Yet all of these sources combined are not enough to power an advanced society. Some suggest we stop all development, or even return to a pre-industrial culture. This may be an appealing idea to those of us already living in wealthy, high-technology societies, but how do you ask a developing country to stop its growth? And who would ask them to deny their children a better future? The facts are clear. We will need major, clean, new energy sources if we are to have a future. But where will they come from? If we assume that the solutions to these problems are limited to this one crowded and fragile planet, the future does indeed look hopeless. Fortunately, that assumption is wrong. Just as the great sea voyages of history gave us a new model of the Earth, which isn't flat and doesn't end at the horizon, more recent voyages of discovery have shown us that the Earth is not alone in space. Our world is just one tiny island in a vast ocean of resources. An ocean containing millions of times the mineral wealth of our planet, bathed in virtually unending clean energy from the sun. Energy which can fuel our hungry world and replace the outdated and dirty forms of energy production which have come to threaten our survival. What keeps us from reaching out to claim this new frontier? We are trapped by our old ideas. Most people see the space around our planet as an environment which is barren, desolate of anything useful, and in fact too dangerous for any but a very few to venture into. They have also come to believe that everything humans need to survive in space must be carried with them from the Earth at great expense. We're forgetting our own history. When the first earthbound pioneers settled new worlds, they didn't bring their houses with them. Instead, they brought tools and used local resources for construction. We can do the same thing in space. By working with natural laws and the space environment, we will discover that the materials we need for building and the fuels we need for travel in space are all there, waiting. We must simply harvest them. This is not a new idea. Successful pioneers have always learned to live off the land, and we have the tools to do it today. The high frontier can be opened now. The Earth's closest neighbor in space is the Moon. It is hard to believe that it has been almost 20 years since the first human being stepped upon the lunar surface, and 15 years since the last. The President's National Commission on Space report, issued to chart America's new course into the space frontier, states that it is time to return. So does a high-level internal NASA study put together by astronaut Sally Ride. Both of these important reports recommend that the next step in opening space is for America to return to the Moon and establish a permanent facility there. Although not in the headlines, in the years since Apollo, many scientists and engineers at NASA, universities, and organizations like the Space Studies Institute in Princeton have been quietly seeking new ways to open space using raw materials from the Moon. At the Space Studies Institute, they have shown that the key to opening up these resources is to keep costs down and to achieve a large output of useful products from lunar soil in a short period of time. To do so, we simply need to imitate the methods employed by farmers for generations. In agriculture here on Earth, we have learned to grow plants to process this planet's soil and air into products. A tree, for instance, is a system which processes earth. Using the roots to extract what it needs for growth, it uses the sun's energy to convert these materials into its own structure. In growing crops, humans enhance this process and profit by it. If properly managed, a single seed can multiply itself 1,000-fold, producing great rewards for a small investment. One of the plans proposed by SSI works the same way. First, we build an outpost on the moon to mine the readily available lunar soil and compress it into baseball-sized pellets. These are launched into space without rockets using an electromagnetic catapult shaped like a tube, known as a mass driver. The mass driver launches a constant stream of these packets into space where they are caught by the second part of the system, a processing facility. Powered by solar energy, this is where the raw soil is converted into construction materials, which are fed into the third element of the system, a job shop. This is a general-purpose manufacturing plant. The job shop is designed to make parts for more mass drivers, processing plants, and additional job shops. The job shop can be programmed by its human operators to produce a wide variety of products. Called self-replication, the system virtually copies itself. The roots of our system are located in the energy-poor but resource-rich environment of the lunar surface. The mass driver is the trunk, lifting the raw materials to the processing plants. The processing plants act like leaves, using energy from the sun to convert the lunar materials into usable form. Like a living plant, the system multiplies. Starting from a small seed, it can double itself every 90 days. To keep costs down, these facilities are what we call human-tended. Much of the control and maintenance is remotely performed by operators back on Earth. People also act as troubleshooters and perform complex maintenance and repair tasks, just like farmers weeding and cultivating a field. The entire system uses no more than the same level of automation found in today's automobile factories. Studies have shown that such a self-replicating system could be planted and begin using lunar resources for about the same cost as the privately financed Alaskan pipeline, or a couple of North Sea oil rigs. And mining materials from the moon hurts no living things. Using lunar resources means enormous savings in supplying materials to human projects in space. One very important project, which up until now has been too expensive to consider, is the construction of solar power satellites, sunsats. These exciting new clean energy sources can be built almost entirely from lunar materials. By harnessing the power of the sun, which is always abundant in space, these solar power satellites will allow us to reduce our dependence on polluting coal and nuclear energy. One of the major causes of famines in North Africa has been the stripping of the countryside in the search for fuel. The result is the desertification of once fertile land. Imagine what one sunsat producing enough energy to power a major U.S. city could do for the people of this region. As more sunsats are built and new jobs are created, we can also create whole new living areas in space using material already there. As we develop means of building these new habitats, we will gain insights into the complex interrelationships that govern natural systems here on Earth. In other words, by going out there, we can do a lot to help solve problems down here. Possibilities only become realities when someone acts on them. Already, researchers at SSI are developing the technology to convert lunar soil into many useful products. An amazing 42% of the moon's soil is made up of oxygen, important for breathing and producing water. And oxygen is also the major component of rocket propellant. Lunar soil contains several metals and can also be used in a raw form to manufacture glass fibers for building materials. The key to getting materials from the moon's surface and into space without rockets is the mass driver. SSI has proved the feasibility of mass drivers, reducing the required length of a lunar launcher from 5 miles to 500 feet. In addition to the known resources of the moon, we are also seeking other sources of materials. These include asteroids, which may be trapped in the Earth's orbit, and possible ice near the moon's poles. Before we can begin using the moon's resources, we must build a bridge to get there. Although the planned U.S. space station is the next logical step in developing a permanent presence in space, we will need more extensive facilities to support operations between the Earth and the moon. We will need them as soon as possible, and at first they will have to be built from materials lifted from the Earth. With launch costs now approaching $4,000 a pound to low Earth orbit, this seems to be a very expensive proposition. What if you were to discover Earth-orbiting supplies of high-grade metals and fuel ready and waiting to be used at very low cost? They do exist. We are talking about the large external tanks of the space shuttle. Of all the space resources available to us, none is more readily available than these structures. These tanks are carried 98% of the way into orbit on every space shuttle flight and contain over $300 million worth of metals and fuel when they are thrown away to burn up in the Earth's atmosphere. We have the means of saving and recycling these potentially valuable assets to our nation's space program. Studies have shown dozens of uses for these tanks, ranging from radiation shielding to observatories. We are also studying methods for keeping these tanks in orbit and managing them until they can be used. Perhaps some of the early space habitats will even be built up from clusters of these tanks. As stays in space increase in length, we will need to provide some form of gravity. It has been proposed that future space habitats be rotated to produce artificial gravity. The development of large industries sending power to Earth will require places to live for large numbers of workers and their families. Ultimately, entire cities will be built in free space. We can build homes for millions of people living in climates of their choice, surrounded by natural, living things. If properly utilized, the resources of space give us the chance to not only begin reversing the damage we have done to our delicate home world, but to carry her life with us where no life existed before. The high frontier offers us the most important resource of all, hope. The question before us today is simple. Will space remain open only for scientists and soldiers? We have the know-how right now to open the space frontier for all of us in our lifetime. All that is needed is for enough of us to decide to make it happen. The benefits of opening space will go beyond the physical and economic. The social effects will be profound. We will create new choices and perhaps whole new societies. The opening of space offers new approaches to our problems here on Earth and will signal the dawn of the grandest renaissance of all time. You have the chance to participate in this adventure. It is all up to you. New solutions, new industries, new jobs are waiting. Only 100 miles above us lies a new frontier, an endless frontier, the high frontier. It is up to us to open the door. Together, we can make it happen. Join us.